Okay, in this second design-related example, we've got a Y-flange steel shape, a W10 by 15, that's subjected to 80,000 pounds in the design scenario, and that material is made of steel. We're asked to find out if this design is adequate in this particular loading case. We have a minimum factor of safety of 1.67. Right? So we're given a W10 by 15. Now, given that it's an axial load, and we're going to start thinking about stresses, then I know that I immediately want to go look up the critical geometric property, which is going to be the cross-sectional area, and that's equal to 4. I need to check real quick. It's 4.1, or no, 4.41 square inches. Right? Different textbooks have different properties listed or different sections listed. You can go to AISC's manual for all of the cross sections, or there's a spreadsheet loaded to the course website from which you can also then find more than just the W shapes, but all kinds of them. So we got to look that number up. It's nothing that we're going to calculate for steel shapes. Right? So we're given that. We're given that our axial force equals 80 kips. We didn't have to do any analysis to get there. That was just given to us. And we're given that the factor of safety minimum is 1.67. And we're supposed to find then is the design adequate, which means is the factor of safety actual greater than the factor of safety minimum. That's what we're trying to then determine. Right? So let's think about this. All right. So if the factor of safety, what is factor of safety again? Factor of safety is our strength divided by our demand. Okay. So here we can calculate what the demand is pretty easily. That's going to be our axial stress, which equals P over A. That's 80 kips over 4.41 square inches. And that's then going to be equal to less than 20 KSI. I like the sounds of this, because at 18.1 KSI tension, I already know right off the bat here the strength for A36 steel is going to be taken as, let's see, with respect to yield, they don't say ultimate or anything else, so we'll have to choose, but let's look at the worst case. That would be yield. That's 36 KSI. And when I then go calculate then the factor of safety actual, that will be our strength divided by our applied, or our demand, and that then is going to be 36 over 18.1. That's going to be pretty close to 2, just a little bit less. It's going to be 1.98. That's greater than the requirement, which is 1.67, so therefore okay.